This is SpaceTime Series 25, Episode 111. Coming up on SpaceTime, astronomers given one of their best views yet of the birth of a black hole, the largest known asteroid impact on Earth, and an Australian project to grow plants on the Moon. All that and more coming up on SpaceTime.
Welcome to Space Time with Stuart Gary.
Astronomers have been given one of their best views yet of the birth of one of the universe's most infamous monsters, a black hole. Their findings, reported in the journal Nature, describe a superluminal jet powering through space at speeds of greater than 99.97% the speed of light, propelled by a titanic explosion as two neutron stars collide. The event, named GW170817, was first observed in August 2017 by LIGO, the Laser Interferometer Gravitational Wave Observatories in Louisiana and Washington State, and by Virgo, the European Gravitational Wave Observatory in Italy. The collision originated in the shell of an elliptical galaxy known as NGC 4993, located about 140 million light-years away in the constellation Hydra. The blast released as much energy as any supernova explosion. Independently, a short 2-second gamma-ray burst, designated as GRB 170817A, was detected by the Fermi and Integral Gamma-Ray Space Telescopes beginning 1.7 seconds after the gravitational wave merger signal. This was the first combined detection of gravitational waves and gamma radiation from a binary neutron star merger. The aftermath of this massive collision was collectively seen by more than 70 observatories around the planet, as well as in space. And it was monitored right across the electromagnetic spectrum, that's in addition to the gravitational wave detection. Consequently, this has heralded a significant breakthrough for the emerging field of time domain and multi-messenger astrophysics, and the use of multiple messengers, like light and gravitational waves, to study the universe as it changes over time. It was also a major watershed in science's ongoing investigation of these extraordinary collisions. Astronomers were able to aim NASA's Earth-orbiting Hubble Space Telescope at the site of the explosion 2 days after the first signals were received. By then, the two neutron stars had collapsed, forming a stellar mass black hole, whose powerful gravity had begun pulling in all the material around it. All this material formed a rapidly spinning accretion disk, and the accretion disk began generating jets moving outwards perpendicular to the black hole's disk. The roaring jet smashed into and swept up material in the expanding shell of explosion debris. This included a blob of material through which the jet emerged. Now, while this event took place back in 2017, it's taken several years for scientists to come up with a way to analyze the Hubble data together with the data from the other telescopes in order to paint this full picture we now have. So the Hubble observations were combined with observations from multiple National Science Foundation radio telescopes working together to provide a very long baseline interferometer. The radio data was taken on day 75 and again on day 230 after the explosion. The study's lead author, Penelope Mooley from Caltech in Pasadena, California, says he was amazed that Hubble could provide such a precise measurement, rivaling the precision provided by the radio telescopes of the Very Long Baseline Interferometer. The authors used Hubble data, together with data from the European Space Agency's Gaia spacecraft, in addition to the Very Long Baseline Interferometer, to achieve extreme precision, taking several months of careful analysis of the data to make their measurements. By combining all these different observations, the authors were able to pinpoint the exact explosion site. Now, interestingly, the Hubble measurement showed the jet appear to be moving at an apparent velocity several times the speed of light, and the radio observations showed that the jet had later decelerated to an apparent speed of 4 times faster than the speed of light. Of course, in reality, nothing can exceed the speed of light, so this superluminal motion is in fact an illusion. It comes about because the jet is approaching Earth at nearly the speed of light, and the light it emits at a later time has a shorter distance to go. So in essence, the jet is chasing its own light. In actuality, more time has passed since the jet's emission of the light than appears to the observer. And this causes the object's velocity to be overestimated, in this case seemingly exceeding the speed of light. When everything is calculated out correctly, it turns out the jets were actually moving at around 99.97% the speed of light when they were launched. The new Hubble measurements, combined with the very long baseline interferometer measurements announced back in 2018, greatly strengthened the long-presumed connection between neutron star mergers and short-duration gamma-ray bursts. That connection requires a fast-moving jet to emerge, which has now been measured in GW170817. The work paves the way for more precision studies to be made of neutron star mergers being detected by LIGO, Virgo, and Japan's new Kagra Gravitational Wave Observatory. With a large enough sample size over coming years, relativistic jet observations might provide another line of inquiry into measuring the universe's rate of expansion, known as the Hubble constant. See, at the moment, there's a huge discrepancy between Hubble constant values as estimated in the early universe and in the nearby universe. In fact, it's one of the biggest mysteries and problems facing astrophysics today. After all, how can we determine where we're going if we don't know how fast we're going there? The differing values are based on extremely precise measurements of Type 1a or thermonuclear supernovae, exploding stars all of similar mass which explode at different distances and therefore allow you to use them as distance ladders to determine the acceleration rate of the universe, as opposed to the cosmic microwave background radiation measurements by ESA's Planck satellite, which measured the earliest light in the universe just 300,000 years after the Big Bang 13.82 billion years ago. More views of relativistic jets will add information for astronomers trying to solve the puzzle. This report from NASA TV.
Astronomers using NASA's Hubble Space Telescope have found a jet propelled through space at nearly the speed of light by the titanic collision between two neutron stars, which are the collapsed cores of massive supergiant stars. The explosive event observed on August 17, 2017, was the first combined detection of gravitational waves and gamma radiation from the merger of binary neutron stars. This discovery prompted scientists to quickly aim Hubble at the site of the explosion. A total of 70 observatories around the globe and in space collectively gathered data across the electromagnetic spectrum of the merger's aftermath. Astronomers used Hubble's capabilities to precisely measure the position and movements of the explosion's shockwave. They were trying to see how the shockwave's physical properties changed over time. Combining Hubble observations with that of several other telescopes allowed researchers to pinpoint the explosion site 130 million light-years away. The data suggests the blast shockwaves traveled along a narrow beam confined by powerful magnetic fields. The resulting jet smashed into and swept up material in the surrounding interstellar medium. This material included a mass radiation through which the jet emerged. As the jet moved away from the site of the explosion, the mass moved outward. This work paves the way for more precise studies of neutron star mergers. More observations like this one help us understand more about the universe.
This is SpaceTime. Still to come, the largest known asteroid impact on Earth and an Australian project to grow plants on the Moon. All that and more still to come on SpaceTime. A new study suggests that the largest known asteroid impact on Earth may have been even bigger than previously thought, and at least twice the size of the one which killed all the non-avian dinosaurs 66 million years ago. The massive space rock, now estimated to be between 20 and 25 kilometers wide, slammed into planet Earth some 2 billion years ago in what is now southern Africa, creating the gargantuan Redefort crater located some 120 kilometers southwest of Johannesburg. The massive scar left from the impact produced a crater some 159 kilometers wide, making it the biggest visible crater on Earth. However, that's far smaller than the famous 180 kilometer wide Chicxulub crater, which is buried under Mexico's Yucatan Peninsula. It was formed 66 million years ago by the impact of the 12 kilometer wide KT boundary event dinosaur-killing asteroid. Scientists believe that 2 billion years worth of erosion would have removed much of Vredefort's original size. But speculation remained as to how big it would have originally been, and consequently how big the asteroid must have been that caused it. Now, a new study reported in the Journal of Geophysical Research Planets has recalculated the size of the Vredefort crater, concluding that it would have been between 250 and 280 kilometers wide when it was formed. The study's lead author, Natalie Allen from Johns Hopkins University, says understanding the largest impact structure we have on Earth is critical. Having access to the information provided by a structure like Vredefort crater provides scientists with an opportunity to test their models and their understanding of the geological evidence so they can better understand asteroid impacts on Earth as well as beyond. Now, for the authors, the big problem was not only the 2 billion years of erosion by wind and water, but also the creation of lots of newer rock formations covering much of the original crater, so that only really small sections of the rim are still visible today, making it even harder to tell how big the crater really was. However, by studying the minerals surrounding the crater, scientists were able to trace the deformations and shock fractures in crystals like quartz and zircon, which were caused by the impact, thereby creating a better estimate of the true blast radius. Now, based on those measurements, Allen was able to calculate the impactor would have been between 20 and 25 kilometers wide. That's twice as big as the KT boundary event dinosaur-killing asteroid. She says it may also have been travelling much faster, between 72,000 and 90,000 kilometers per hour when it hit the planet. That means the impact would have been even more severe, potentially the single largest energy release event in Earth's history. However, unlike Chicxulub, which killed 75% of all life on Earth, the Vredefort impact didn't leave a record of mass extinction or global forest fires. That's because the only life on the planet 2 billion years ago were single-celled organisms. Still, the impact would have affected global climate, potentially far more extensively than Chicxulub did, so there's still lots of studying to do. This is SpaceTime. Still to come, an Australian project to grow plants on the moon, a Japanese rocket explodes during launch, and later in the science report, a new biodegradable material designed to replace conventionally used plastics. All that and more still to come on SpaceTime. Australian scientists have announced plans to grow plants on the moon to help pave the way for future lunar colonies. Biologist Brett Williams from the Queensland University of Technology says the seeds would be carried aboard the Bereshit 2 spacecraft, which is now being built by an Israeli non-profit team. They'd be planted in a sealed container which would be watered after landing on the moon and then monitored for signs of germination and growth. The Australian Lunar Experiment Promoting Horticulture, or ALEPH project, is an early step towards growing plants for food, medicine, and even oxygen production on the moon, all of which will be crucial for establishing human life on our nearest celestial neighbour. ALEPH, meaning one or A in the Hebrew alphabet, will be the first of a series of experiments to investigate whether plants can not only tolerate but maybe even thrive on the lunar surface. The project's an international collaboration involving not just the Queensland University of Technology, but also RMIT University, the Australian National University, and the Ben Gurion University in Israel. SpaceIL says the Bereshit 2 moon mission would launch in late 2024, touching down on the lunar surface in early 2025. The spacecraft would include an orbiter and 2 landers. 7 countries, including Israel, Australia, and the United Arab Emirates, will participate in the project. Japan suffered a major launch failure, with its Epsilon rocket exploding during the final stage of its flight to orbit. The 24-metre-tall solid-fueled rocket had taken off from the Uchinori Space Center in the southern Kagoshima region. It was carrying the 110-kilogram RAISE-3 Rapid Innovation Payload Demonstration Satellite. The satellite was loaded with 7 experimental technology payloads and 5 rideshare CubeSats. Initial reports indicate the rocket's first and second stages performed nominally. However, the third stage failed, forcing mission managers to issue a self-destruct order. The Japanese Aerospace Exploration Agency JAXA are now trying to determine exactly what went wrong. This is SpaceTime. that's the show for now. SpaceTime is available every Monday, Wednesday and Friday through Apple Podcasts, iTunes, Stitcher, Google Podcast, Pocket Casts, Spotify, Acast, Amazon Music, Bytes.com, SoundCloud, YouTube, your favorite podcast download provider, and from spacetimewithstuartgary.com. SpaceTime's also broadcast through the National Science Foundation on Science Zone Radio and on both iHeartRadio and TuneIn Radio. And you can help to support our show by visiting the SpaceTime store for a range of promotional merchandising goodies, or by becoming a SpaceTime patron, which gives you access to triple-episode commercial-free versions of the show, as well as lots of bonus audio content which doesn't go to air, access to our exclusive Facebook group, and other rewards. Just go to spacetimewithstuartgary.com for full details. And if you want more SpaceTime, please check out our blog, where you'll find all the stuff we couldn't fit in the show, as well as heaps of images, news stories, loads of videos, and things on the web I find interesting or amusing. Just go to spacetimewithstuartgary.tumblr.com. That's all one word, and that's Tumblr without the E. You can also follow us through @StuartGary on Twitter, @SpaceTimeWithStuartGary on Instagram, through our SpaceTime YouTube channel, and on Facebook, just go to facebook.com/SpaceTime with Stuart Gary. And SpaceTime is brought to you in collaboration with Australian Sky and Telescope magazine, your window on the universe.
You've been listening to SpaceTime with Stuart Gary. This has been another quality podcast production from Bytes.com.